In this lecture, I want to solve some problem about the interpolation for you. But before that, I ask you please watch this video and my other lectures online, and please do not download it. The first example, let me try to solve the first one. Exercise number 1. Find the Newton interpolating polynomial for the following nodal points. Suppose that we have some nodal points through this form. Let me write xi and fi. In fact, this is fi. Okay, so let me write 0, 1, -1, 2, and 3. And the value of f will be 0, -1, 3, 0, 3. Okay, we know that we have to use the finite difference for computing the coefficients of Newton polynomial. So let me first compute f dot. Okay, for this one it will be appear here, and it will be this item minus this one over this one minus this one. So minus 1 minus 0 over 1, it will be minus 1. The other one, 3 plus 1, 4 over minus 2, it will be minus 2. And in the same way we continue. 0 minus 3, 2 minus 1 will be minus 1. This 3 minus 0 over 1, it will be 3. Okay, and it's all. The other one, I should compute f dot. This item, and this item. Minus 2 minus 1 minus 1 over minus 1, it will be plus 1. Minus 1 minus 2, it's 1 over 2 minus 1, it will be 1. And the other one, 3 plus 1 over 3 plus 1, it will be 1. Okay, and the other one, f dot. 1 minus 1 will be 0, and the other one will be 0, and finally I get dot, it will be 0. Now I can write easily the polynomial of degree at most 5. Okay, let me write it. P of x equal to, now I have to use this one, this one, this one, this one, and this one as coefficient of the Newton polynomial. So P of x will be this one, f of x 0, it will be 0 minus x minus 0 plus x minus 0 times x minus 1, and because these two other coefficients are 0, we need not to continue, and we can just simplify these terms. So it will be minus x plus x squared minus x, and it will be x squared minus 2x. 1 point. We saw that we had 5 nodal points, and we expect that we have a interpolating polynomial of degree 4. but the degree of the interpolating polynomial is just 2. This is because of 2 last coefficients. So it's not necessary that the degree of the interpolating polynomial always be 1 less than the number of the nodal points. It will be at most the number of nodal points. And the other important thing, suppose that we add a new point here. For example, we add 5 and for example 1 here, a new nodal point. So we need not to compute all the terms again. In fact, if I want to find the new Newton polynomial, I have some parts of the polynomial and it will be here, okay? And I just need to compute some new terms. For example, from these two, I can compute this term 1 minus 3 minus 2 over 2, it will be minus 1, okay? And from these two, I have minus 1 minus 3 minus 4 over 3. It will be minus 4 over 3. And here, I have to compute minus 4 over 3 minus 1. It will be minus 7 over 3 over 5 minus 1. It will be 6. So it will be minus 7 over 18. And from these two, I get minus 7 over 18 over 5 minus 1, 4 in fact. It will be minus 7 over 72. And finally, I find a new term here. It will be minus 7 over 72 over 5 times this one. It will be 360. So if I want, for example, to compute the new p of x, it will be this term, in fact x2 minus 2x, okay? And I have to just add this term, minus 7 over 360 times x minus 0 times x minus 1 times x plus 1 times x minus 2 times x minus 3, and it will be a polynomial of degree 5, and it's over. We need not to compute every in fact terms again. This is the advantage of the Newton polynomial against the Lagrange polynomial. If I want to compute the Lagrange polynomial, I have to compute again everything that I have computed before. And in fact, this is very, very important. Let me solve another example. Suppose that, let me write the problem here. Let f of x be a function and x0 to xn be n plus 1 distinct nodal points. Nodal points? No, not nodal points. Points. Okay. Define a new function, call it g of x equal to f of x0, x1, 2, xn, and x. In fact, g of x is the divided difference of x0, x1, 2, xn, and x. Okay, now show that g prime of x is equal to f of x0, x1, 2, xn, and x. We want to show this one. Okay, now if I want to prove this problem, first of all we define a let me tell you something first. Solution. In fact, we have to use induction over n. In fact, we have to use induction. First of all, define gi of x to form f of x0, x1, 2, xi, and x. Okay, and let I be equal to 0. So g0 of x will be f of x0 and x. Okay, let me tell you something here. Accept that f of x and x will be equal to f prime of x. We can prove it. The proof of this in fact equality is not difficult. You can use the definition of the derivative and use the divided difference and prove it easily. So let me accept this one. Now we have to compute two things. First of all, f of x0, x and x, and the other one we have to compute g prime of 0. Okay, so we have to compute g prime of x and f of x0, x and x. If these two terms will be equal, so the problem is solved and everything. In fact, the first step of induction is correct. So let me compute, for example, this one first. Okay, so let me consider f of x0, x and x. By the definition of the divided difference, it will be f of x and x minus f of x0 and x over x minus x0, and this one will be f prime of x by this one, so it will be f prime of x over x minus x0, and the other one it will be f of x0 and x over x minus x0. We keep computing x minus x0 minus x minus x0, and here we can write f of x minus f of x0 over x minus x0. Okay, let me do some more computation. It will be f prime of x over x minus x0 minus, and here I can write f of x minus f of x0 over x minus x0 squared, and finally we get f prime of x over x minus x0 minus f of x over x minus x0 squared plus f of x0 over x minus x0 squared. Keep it and call it star. Okay, this will be star. In fact, this is f of x0, x and x. Now let me compute g prime of x. In fact, g0 prime of x. Let me write first g0 of x. g0 of x, it is f of x0 and x, and this is f of x minus f of x0 over x minus x0. So if I continue and compute g prime 0 of x, it will be, let me write one more simplification here, and I write f of x over x minus x0 minus f of x0 over x minus x0. Okay, now let me compute the derivative. The derivative of denominator, it will be f prime of x times denominator minus 1 times denominator over denominator squared, and here plus f of x0 over x minus x0 squared. And if I simplify these terms, I can get f prime of x over x minus x0 minus f of x over x minus x0 squared plus f of x0 over x minus x0 squared. And you keep it and call it double star. Okay, compare star and double star. So you can get the first step of induction is proved. So I say by star equal to double star, we can get g prime 0 of x will be f of x0 and x. This is in fact the first step of induction. Now let for I equal n, the in fact the assumption of the induction is true. So now let for I equal to n, okay, we have gn of x is equal to f of x0 to xn and x, and g prime n of x will be f of x0 to xn, x and x. Let these two things are true. Now we have to prove for n plus 1, for I equal to n plus 1, we have to prove for n plus 1, I equal to n plus 1. So in fact we have to define gn plus 1 of x equal to f of x0 to xn and xn plus 1 and x. Okay, and now we have to compute two things, g prime n plus 1 and fx0 to xn plus 1, x and x. So now have to compute g prime n plus 1 of x and f x0 to xn plus 1, x and x. Okay, so let me start to compute. First, let me compute the second term. Let me start with f x0 to xn plus 1 x and x. Okay, this is equal to in fact f of xn plus 1 x0 to xn x and x. We know that in the divided difference the arrangement of the in fact elements in the bracket is not important, and you can move, you can in fact change the place of every of these terms. So in this case I move xn plus 1 from here to the first of the function. Okay, and now I can write the definition of the divided difference. It will be f of x0 to xn x and x minus f xn plus 1 x0 to xn and x over x minus xn plus 1. Okay, now if you consider this one, we proved this item is exactly here, g prime n of x. Okay, we had this by the assumption of induction. So I can write here for this one g prime of n of x minus f of xn plus 1 x0 to xn and x over x minus xn plus 1. Okay, now let me continue to the computation. So I can write g prime n of x over x minus xn plus 1 minus, and I write it in the by the definition of divided difference. So I can get f of x0 to xn and x minus f of xn plus 1 x0 to xn over in fact 1x minus xn x minus xn plus 1 appear here, and the other one again appear, so it will be 2 power of 2 or squared. Okay, so let me continue. I can write g prime n of x over x minus xn plus 1 minus here f of x0 to xn and x, it will be it was gn of x. Okay, I put it over minus xn plus 1 squared, and the other one will be plus f of, and again I move this term to the last one, so I put x0 x1 to xn and xn plus 1 over x minus xn plus 1 squared. Okay, keep it and call it number 1. Now let me compute g prime of n, in fact. So let me compute the other term. Let me start with gn plus 1 of x, that was f of x0 x1 to xn and xn plus 1 and x. Okay, now let me move xn plus 1 from here to the first, so I can get f of xn plus 1 x0 x1 to xn and x, and let me write it to divided difference format. So it will be f of x0 x1 to xn and x minus f of in fact xn plus 1 x0 to xn and x. Okay, and it will be over x minus xn plus 1. Now consider the first term. It was exactly gn of x over x minus xn plus 1, and the other one, let me keep it and write it f, again move xn plus 1 to the end, so it will be x0 x1 to xn plus 1 and x over x minus xn plus 1. Okay, now let me compute. In fact, here I get gn plus 1 of x is equal to this one. Now let me compute g prime n plus 1 of x, and the derivation of this one is not hard. It can be computed easily. Gn of x times x minus xn plus 1 minus gn of x over x minus xn plus 1, and here we have just the minus should be plus, and we get x0 x1 to xn plus 1 and x. Let me check something. Maybe something wrong here. Yeah, something wrong. It is not correct. It should be just n, and of course here I don't have any x, and also here. Yeah, now it's correct. Over x minus xn plus 1 squared. Okay, now if I write it something like this, it will be g let me see something. Yeah, it will be squared, in fact. So I can get g prime n of x over x minus xn plus 1 minus gn of x over x minus xn plus 1 squared plus f of x0 x1 to xn plus 1 over x minus xn plus 1 squared. Keep it and call it number 2. Okay, now compare number 1 here, look at it, and number 2. They are exactly the same. Okay, so by 1 equal to 2, we get g prime n plus 1 of x equal to f of x0 to x n plus 1 x and x. And this complete the proof of the problem by induction. So let me stop this lecture here. In the next lecture, I also will solve some problem about the Lagrange and other kind of interpolation. Please subscribe my channel, follow my channel, and please watch all of these videos online and don't download it. Thank you.